Chapter 8, Assignment A, which is problems 1, 5, and 6. Number 1. Use figure 1 on page 120 to answer the following questions. What is the height of the shortest father? So where do you find the shortest father? As far to the left as possible. Let me take a picture of this. All right. So, oh, it didn't work. Sorry. Huh. Hey, somebody run up and push the little camera button while I hold this. Come here. Come here. Up on the board. At the bottom left of the picture, there's a little tiny camera. Put your finger out there. Down. Yeah, there. Nope. I don't know why it wouldn't take it from over here. It's supposed to. Good job. I don't need you anymore. Okay. The shortest father, this is the list of fathers. So the shortest one has to be as far to the left as we can get, which is that guy right there, 59 inches. How tall is his son? So this person right here is just over 65 inches. Looks like 65 and a quarter maybe. Okay. B, what is the height of the tallest father? So we're going to go as far to the right as we can, which looks like this guy. And I can't see that. It's off my page. 75. And how tall is his son? 70. Now, that's kind of interesting. The shortest father was 59 inches, and his son was 65 inches. The tallest father was 75 inches, and his son was 70. Is that a little strange to you? The shortest father's son was taller than him, and the tallest father's son was shorter than him? Okay. Now, there's something at work here, and we talked about it a little bit last time. If we look at this column here, okay, that is everybody who is 72 inches tall. Every father. Every father that's 72 inches tall. And what does that diagonal line represent? It's the slope of 1. So anybody that lands on that line is not average, right? The same as the father is the same height as the son. Okay, if you land on that line, then you are a father who is the same height as the son. Or you could say it the other way around, but that's not how this graph is built. Okay, now notice, in this, it called it a chimney. I'm going to call it a column. In this 72-inch father column, what does it look like the average height of the sons would be? So if I were to take this blob here and cut it in half, I would end up somewhere in there, 71 inches. Maybe 7. Yeah, that's not very right. How about 70? So that's kind of weird. Fathers who are 72 inches tall have sons that are on average 70 inches tall. Okay, you wouldn't have guessed that, right? So there's something at work here, and we'll get into that in a little bit. For now, let's continue problem 1. C, take the family where the father was 72 inches tall. How tall was the tallest son? So in this column here, the tallest son, 77, 76. Okay. And the shortest son, 65, 64. Apparently you guys don't like me. Okay. How many families are there where the sons are more than 78 inches tall? Where are we looking? Above a horizontal line at 78. 2. Okay. Um, how tall are their fathers? So straight down, 69. Uh, I got, okay, 69, 70. Apparently I can't draw vertical lines. Oh, my graph isn't straight. That's the problem. My graph is tilted. Hey, I can fix that. There we go. Not sure if that's any better or not. Okay, now, wait a minute. That's kind of interesting. Sons that are 78 inches tall both had fathers that were shorter than them. Hmm. The book is trying to get at something that we'll learn in just a little bit. Okay, what was the average height of fathers around 64, 68, or 72? So if we were to look at all of the fathers, okay, so basically we need to draw a line down the middle that represents the weighted average. Remember, we're not cutting the people in half. That's a median. We're cutting their weights, or in this case, their heights in half. So would that line belong at 64, 68, or 72? 68. Okay. And um, you know how we talked about the bell curve? If we have a normal curve, then the median and the average are in the same place. But that's for one variable. All we have is an x-axis. We don't have a y-axis. If we're dealing with an x and a y-axis, we don't look for a bell curve, we look for a football. So does it appear that this stuff is football shaped? Yes. So, and footballs can be, they can kind of look like a football or maybe more like the cross section of a frisbee. Okay. If it looked like a circle, if it looks like a circle, that doesn't do us any good, right? There's no correlation. Okay. So what would be not football shaped? And it would be something like a peanut. Okay. That's not the normal curve in 2 dimensions. Or you could also have something that looked kind of like a megaphone. That would not be a normal curve. But if your scatter plot is shaped like a football, then the median and the average are in the same place. Okay? So football shapes are good in 2 dimensions. Normal curves are good in 1 dimension. And it turns out, if it's football shaped, we can treat it like it's a normal curve and do the same things that we've done before. But you're not going to see that for a little bit. Okay. And was the SD of the father's height around 3, 6, or 9 inches? So we know that the average is here for fathers. How do we check for SD? What do we know about the SD in the normal curve? 68%. So if I go out 1 SD, whatever that is, I need to capture 2/3 of the people. So I'm off a little bit again. Do I capture about 2/3 of the people there? That might be a little too big. So what would you say? 3, 6, or 9? 3. So an SD of 3. If I go, that would work too. So 1, 2, anyway, it's got to be 3. 6 is way too big. 9 is even bigger than that. Okay, number 5. Students named A, B, C, D, E, F, G, H, and I, and J took a midterm and a final in a certain course. A scatter diagram for the scores is shown on the next page. So if you look on the next page, this scatter diagram, it tells you what their midterm score was, and it also tells you what their final score was. Let's see if this will... Still won't take pictures. Yep, somebody can push the button. There's a camera button on the camera, but it... Oh, perfect. So, looking at that graph, which students scored the same on the midterm as on the final? A, F, and B. Why? They are on... Nope, that's not going to work. They are on this line here. Just to be a little more explicit, what is the equation of that line? Y equals X. So this is the midterm is equivalent to the final. X is midterm, Y is final. So Y equals X would be the line where the two graphs are identical. Okay. And B, which students scored higher on the final than they did on the midterm? Everybody that is above that line. Right? This right here would be final is greater than midterm. And down here, this would be final is less than midterm. Okay. C, was the average score on the final 25, 50, or 75? So average on the, what did I say? Average on the final. So average on the final, I need to create a horizontal line that puts the weighted average in the middle. Okay. Is this graph football shaped? No, it's not, because we kind of have this. If it wasn't for A, if I threw out A, would it be football shaped? Yes. And what can you tell me about person A? They're in the wrong class, right? Or they didn't try. Yeah. So is this a case where it might make sense to throw out person A? Yeah, because they came in not knowing anything, and when they left, they hadn't learned anything. So you're dragging down my average. I wish I could do that. Okay, was the SD on the scores of the final around 10, 25, or 50? So we want the average distance from the average. So 10 would put me up to 60. Do I capture 2/3 of the data with the 10? No. But if I went up 25 and down 25, do I capture 2/3 of the data? Yeah. Now the problem is this is not normally distributed, so that rule isn't really going to work because of person A, but without person A, it would work. Okay. For students who scored over 50 on the midterm, was their average score on the final around 30, 50, or 70? So who are we looking at? So I'm going to look at which side of the graph? The right side. So I'm going to take 50, and I'm just going to look at those people. Where was their average score on the final? Right there. Yeah, you only have the choice between 30, 50, or 70. So it's got to be 30. Now that's weird. People who did really well on the midterm didn't do as well on the final. Wonder why that's the case. F, true and false. On the whole, Students who did well on the midterm also did well on the final. False. Right? The people who did well on the midterm did not do well on the final. And G, true or false, there is a strong positive association between midterm scores. No, if there is an association, it's negative. Would you say it's a strong negative? And that is the skinniness of our football. So if I got rid of this, it's a little bit megaphone shaped, not too bad. And maybe this person cheated. I don't know. It happens. Of course, who did they cheat off of? That's the question. They're the only ones that got that high. So with A and C included, I would say it's a weak negative association. If A and C and perhaps B were gone, that would be a strong negative because they're really close to a line, right? It would be more frisbee shaped than football shaped. All right, number 6. Okay, Megan, need your help. I wonder why my camera button quit working on me. Hold on. Okay, go for it. Scatter diagram below shows scores on the midterm and a final in a certain course. Was the average midterm score around 25, 50, or 75? What are we looking for here? We're looking for the average of the X's. Is this football shaped? Yes. It's more of a frisbee. It's a really thin football. And when that happens, the average and the median are in the same place. So really all we have to do is divide the people in half, and we get 75 somewhere. Maybe I'm off just a bit. There we go. Right there. Was the SD of the midterm around 5, 10, or 20? So I go out 5 and 5. Do I capture 68%? No. Go out, what's the next option? 10. So go out 10 and 10. That looks like about 2/3. Okay. Was the SD on the final scores around 5, 10, or 20? So the final scores, I'm going to say the average is what, 55? And if I go out 10 and 10, do I capture 2/3 of the data? No. So it's got to be bigger than 10. If I go out 20 and 20, does that take up 2/3 of the data? Yep, so it's probably 20. Which exam was harder, the midterm or the final? Final, why? Because you have lots of experience. Okay, that doesn't cut it. Looking at the graph, how come? So the range of the final is from like 5 points to 100 points. Yeah, one kid aced both of them. Nobody scored less than 55 on the midterm. So, but there is one number we know that tells us that the midterm, well, I guess it's 2 numbers. The average of the midterm was 75 with an SD of 10. The average of the final was 55 with an SD of 20. So the average of the final was much lower and the SD was much higher, which meant we were more spread out and we had a lot of people that scored in the low range. Okay. Was there more spread in the midterm or the final? Final, because the SD was twice as big. True or false? There was a strong positive association between midterm scores and final scores. True. The slope is positive, okay, and our football is really skinny, which means it's a strong association.